Okay guys, so now example 4 on section 10.7. So section 10.7 again, which is, so this one, complex numbers, 10.7, example 4 now. So it says here to multiply the complex numbers, write the product in the form a plus bi. So remember this one, it's a number that's imaginary part. The number comes first. So here it's just a very simple monomial times a monomial. 7 times 3 negative would be negative 21, and then I times I would be I squared. So don't forget, I'm gonna put it here, notes. I squared equals negative 1. So I squared equals negative 1. So that means this part would be equal to negative 1. So that means negative 21 times negative 1 would be 21 positive. So we don't have the I, but you can include it with the 0. So plus 0i. Since they want the complex number, that would be it. So the result plus the 0i. Okay. For this one we're gonna distribute. So 3 times 2. So I'm gonna do it the long way. 3i times 2 positive, so positive, positive, minus, so minus 3i times I. So 3 times 2 would be 6i minus 3 times 1 is just 3. I times I is I squared. So this becomes 6i minus 3 times, remember I squared is equal to negative 1. So this becomes negative 1 in parentheses. So again, you have 6i, negative 3 times negative 1 would give you positive 3. Now remember, complex numbers, they want the number first. So you would just switch this ones like this. This is the I. That would be the answer for that one. Now this one, you're going to use the FOIL. So 2 times 4, 2 times 4, and then 2 times, so positive, positive, so positive, 2 times I, and then the one inside. Negative, positive, so negative 5I times 4, and then this one. Negative, positive, so negative 5I times I. So 2 times 4 is 8. 2I. Negative 5 times 4 is negative 20I. Negative 5I times I squared. So now let's do 8 plus, you can actually combine these two. 2i minus 20i gives you negative 18i. And I'll put the negative by itself later. So negative 18i minus 5i squared would be negative 1. This is an 18. So this would be 8 plus negative 18i. 5 negative times 1 negative would be plus 5. So 8 plus 5 would be 13. And then I'm just going to leave the negative now. Negative 18i. At the answer number comes first, imaginary part comes second. When you get this, all you have to do is multiply the base twice. If this number tells you how many times to multiply the base, and then you do the FOIL. 2 times 2, 4. I'm going to skip steps down. So 2 times -1, negative I mean, would be negative 2i. Negative, positive, so negative again 2i. Negative, negative, positive I squared. So you are able to combine these two in the middle. So 4 negative 2 minus 2 would be negative 4i, plus this becomes a negative 1, right? I squared is equal to negative 1. So 4 minus 4i minus the 1 here. So 4 minus 1 combined like terms would be 3, and then this 3 minus 4i. Now this one. So again, 7 times 7, 49. 7 times 3, negative, so negative 21i. 3 times 7, positive this time, would be positive 21i. Sorry, this is a 21. And then this times I would be negative 3 times 3, 9, I squared. So you combine these two, the one is negative, the other one is positive. So these two become zeros. So you have 49 minus 9 times I squared would be negative 1. So 49 negative times a negative would be positive 9. So this would be 58. Since we don't have the imaginary part, you're going to put it as 0i. That's the answer. Okay, example 5. Divide, write in the form a plus bi. So for these ones, we're going to use conjugate. Let's see. Yes. Multiply and multiply by the complex conjugate. So it's called here a note. Multiply denominator by b complex conjugate. So remember this stuff. So what is a complex conjugate? If you guys remember from the previous lessons, you keep the same terms and change the sign here. So all we need to do with this one is we're going to multiply by 1 plus I, 1 plus I. Because they want us to divide and leave it in this form. If you just see that, there's nothing you can do by looking at it and trying to divide just by regular division. You can't. You have to adjust it by multiplying by the complex conjugate in order to get rid of that complex number in the denominator. So that's what we are trying to do. We're multiplying by that conjugate to eliminate the imaginary part here in the denominator. So you just multiply like that. So the top parts would be 2 plus I times 1 plus I. And the bottom part would just be 1 minus I and 1 plus I, like that. And then you do FOIL for both. So let's do the top. So I'm going to go down like that. 2 times 1 would be 2, and then 2 times I plus 2I, and then plus I or 1I, and then plus I times I would be I squared. In the bottom part, 1 times 1 is just 1, 1 times I is just I or 1I, negative I times 1 would be negative 1I, and then negative positive would be negative I times I is I squared. So let's combine, we can combine these two, and that's 2. So the top would be 2i plus 1i would be 3i, and that becomes a negative plus negative 1. Right? Don't forget that I squared is equal to negative 1. Don't forget this. And then the bottom would be 1i minus 1i. Well, these two go away, and that's why you do the conjugate to eliminate the imaginary part from the denominator. We already did, because that one, becomes a negative 1. So the top becomes 2 plus 3i minus 1. And this becomes 1 minus minus minus. 1 minus times minus gives you positive 1. So 2 minus 1 gives you 1 plus 3i. 1 plus 1 gives you 2. If you give me that answer, that's perfectly fine. Or you can separate this 1/2. Separate these rational numbers. 1/2 plus 3i over 2. And that would be fine, like that. Or I'll give you all the options. 1/2 plus 3/2, and then the I on the side. And I think this is the most formal one, this one right here. You want to get all formal about the math here. This one would be the most, because it looks exactly like the complex numbers. The I on the side, and then the number, and then the other number. Number, and then number, and then the I on this right next to it. Number, number, and then the I right next to it. So it's up to 4. Okay, for this one, you would also multiply by the conjugate also again. So remember, this is a monomial, so the conjugate would be the opposite sign. So you're keeping this, but you're changing the sign. Like that. So now multiply across, so 7 times 3 would be negative 21i over 3 times 3, negative 9. I times I would be I squared. So negative 21i over negative 9i squared, remember, becomes a negative 1. So negative 21i over negative 9 times negative 1 would be positive 9. And you can actually simplify this thing by 3. So negative 21 divided by 3 would be 7. Still negative. And 9 divided by 3 would be 3. And then you still have the I. Now if you want to make it look like that, we don't have that constant, the number, so you're going to put 0 and then minus, because it's negative 7/3, and then the I here on the side, make it all fancy. That would be the final answer. That would be the complex form. I mean, if you got close to this, that would be great. but that would be the final. Okay, the last ones. So for example 6, all of this they're giving you the powers, so it's finding powers of I. So you know the first one was I squared equals -1, and you know I'm gonna put it here, you know I is equal to the square root of -1. We're not gonna use this one. You know I squared is equal to -1, and they want to find the subsequent ones, the next ones, I cubed for example. So all they're doing is separating this I cubed into I squared times I. If you add these exponents, they will give you that cube. So why did they do this? Because they know that I squared would be -1 because of that. And then that I just stays as I, and then you multiply that -1 times the I, it would give you -I. So they know I cubed would be -I all the time. Now I4, all they did again was separate it into 2 and 2. So I squared times I squared. Y2 plus 2 gives you that 4. And they know that I squared again is -1. So they know this part is -1. They know that part is -1. -1 times -1 gives you +1. So again, I4 would be +1. They know that. And they did this one and that one. That's what I gave them. They gave you the 4 examples: -I when it's -I, when it's +1, when it's +I, and when it's -1. So -I to the 5 would be 4 and 1. 4 plus 1 gives you 5. They know from the previous one that I4 is 1, so they know this part is 1. And they still have the I. So 1 times I will just give you I. The last one they give you is I to the 6. They separated them into 4 and 2, right? 4 plus 2 gives you 6. They know 4 from this one it's equal to 1, so this part is equal to 1. And they know I squared from the beginning that's -1. So this one is -1. 1 times -1 gives you -1. So again, they know I6 from the start, it's -1, they don't have to do all of this. For this one, you don't have to do all of this. You will know what the answer is for this 3. And they give you more here. They give you up to 12. So it's a pattern if you guys see it. I, -1, -I, +1. I, -1, -I, +1. I, -1, -I, +1. You guys see it, it's a pattern. It keeps repeating after that. The first 4, the second 4, the first 4, you repeat the pattern. So I7. So I know I7 would be this, right? But if you were expanding it, because that's what they want you guys to know, I would expand this as I using this 4 only. I'm gonna use this 4 only. As I could use 6, you could use 4, I'm gonna use 4. I4 times I3. So I know I4 is +1, so this part becomes +1 times. Let me separate these things. And then I3, I know I3 is -I. -I. So I know I7 would be 1 times -I, which gives me -5, which is the one here. Sorry, I wasn't showing it. So I7 I separated into 4 and 3. I have to do 4 times I to the 3. And then I know I4 would be based on this is 1. I know I3 based on this is -I. So -1 times -I gives you -I, which is I7 is right here. So it matches. It is the right answer. So I20, we don't have that one if you can see. Now if you want to use one of these, that's fine. So I would separate it into I'm going to use 10. 10 times I10, for example. 10 plus 10 gives you that 20. What's I to the 10? -1. So I know this part is -1. I know this part is also -1. So negative 1 times negative 1 gives you positive 1. And that would be I-20. Okay. And there's different ways how to do this. You could have done it like this. Or you could have done powers like I to the 4 raised to the 5. When you do power to a power, you multiply, so 4 times 5 gives you 20. You know this part in the inside is 1. And then you still have that 5 outside, but 1 raised to any power would just be 1. That's another way to do it. You can do it with this one because using powers, because that's a prime number, you can't really factor it. So you use that. This one again, you can use both. You can either find something here that divides it, and then so I-46 would be I-44 times I to the second power. So 44 plus 2 gives you 46. 44, you can break it down into I4 raised to the 11 times I to the second power. So I4, you know it's 1 raised to the 11, and you know I squared it's the negative 1. So I 1 to the 11 is just 1 times negative 1. This will give you negative 1. And I'm going to stop right there.